In this problem, we have to find the initial charge and the final charge. So this capacitor, the 40 microfarad capacitor, is charged capacitor. And initially it has a charge of 5 microcoulomb. And you see the switch is open. So the total charge is only onto this capacitor. When the switch is now closed, then the charge will be redistributed. Then you have to find out what is the final charge onto all these capacitors, onto the system, or onto the all 4 capacitors. So you have to find out the initial charge of the system and the final charge of the system. When I say the initial charge, that means before the switch is closed, and after, or the final charge or the final energy, that means after the switch is closed. So let's talk about this capacitor. So this capacitor, I'm calling C1, let's call this C2, C3, and C4. This capacitor has the charge. So what is the initial system? These capacitors are initially all uncharged. So the only energy stored onto the system is on this capacitor. So the initial charge is given by Q square over 2C. I mean, I can use this formula to have CV square. This is also for calculating the energy stored in a system. But here, as the charge and the capacitance is given, I'm going to use this formula. The Q, the charge onto this capacitor, is 5 microcoulomb. So 5, you have to change that to the coulomb. 5 times 10 to the 6 square divided by 2. And the initial charge is only onto this capacitor. So I'm going to use C1. 2 times C1 is 40 microfarad. 40 times 10 to the negative 6. So the answer you will get is 10 to the negative 6 joule. In other words, the initial charge onto the system is 0.313 microjoule. That's the initial charge stored into the system. And now, in order to calculate the final charge, you have to find out the total capacitance. Now see now. So these two capacitors, C2 and C3, are in series. Okay? The C2 and C3 are in series. And then these two, C2 and C3, are in parallel with the C4 and C1 after the switch is closed. Let me close the switch and redraw here. I'm going to redraw here. Once the switch is closed, how does it look like? You have this capacitor, C1, and then you have C4 here, and then I'm replacing C2 and C3. So this is C1, this is C4, and this is C23. The C2 and C3 are parallel or in series. C2 times C3 divided by C2 plus C3. Okay. And all are in parallel now. So how do you find out the effective capacitance or the net capacitance? So the net capacitance or the equivalent capacitance, C equivalent, or the net. You see these two are in parallel. So I'm going to write down C1 plus C4 plus C23. Alright? Because all are in parallel. So what is the value of C1? I'll just go one more step, C4, and C23, C2, C3 plus C2 plus C3. write down all the values now. C1 is 40. This one is C4 is 14. C2 is 10 microfarad. C3 is 15. 10 plus 15. If you do your math, the net capacitance you will get is 60 microfarad. This is the C equivalent. I'm just writing A equivalent. So now the total charge onto the system, which is the U final, the final charge, the final charge is given by U final is Q square over 2 C equivalent. The total capacitance, the charge does not change. The total charge of the system is exactly the same as before closing the switch. It's the only thing happens is the redistribution of charges. The charge, the 5 microcoulomb charge initially and after is exactly the same, but now the 5 microcoulomb charge is distributed onto these capacitors as well, but the total charge is the same. So the Q is 5 microcoulomb. 5 times 10 to the negative 6 square 2, and the C equivalent is 60 microfarad times 10 to the negative 6. Do your math, and what the final answer you will get is, I'm writing right now here. I hope you can see it. It's 0.208 microjoule. This is the final charge onto the system. Remember, the initial charge is not equal to the final charge, as it takes certain amount of energy to move these charges onto the different capacitors. So there is energy work done in moving the charges onto the different capacitors. Alright? So this is the initial charge energy, and this is the final energy.